Right, well, as part of this Einstein project, I'm going to tell you about hunting for adverse reactions to medicines through stories. And I'm going to tell you several stories. I'm going to say why stories are important and how we interpret them. This is the story of Leopold Myler, a Dutch physician, got tuberculosis, treated with nasty compounds that gave him adverse effects. He wondered what the evidence was. He went looking for it and couldn't find it, so he wrote the book. And this book in Dutch, you may not be able to read the title, in English means Side Effects of Drugs. It was very successful, and he published an English translation, the little black volume there, and then 7 updates every 3 or 4 years thereafter. He died in between the last 2, and a guy called Graham Jukes took over. But as you can see, it increases in size as you go along. There's the graph of the page numbers with time. So what we then did was to start publishing single volumes every year instead of every 4 years, which those other volumes were. And here they are, including the very latest, volume 35. And there's the page numbers. You can see they increase with time, but the last 5 years, huge increase. This is very important. At the same time, we've been publishing encyclopedic versions. 9th, 10th, 11th, 12th, 13th, 14th, 15th edition is 6 volumes. Gets bigger and bigger all the time. This subject is growing. It's online, and there's the page numbers in the encyclopedias. Here are the data on PubMed numbers. All papers in green, 5-fold increase since 1966. All case reports in blue, a 7-fold increase. All case reports of adverse events, 10 to 11-fold increase. It's huge. Interest in adverse reactions, side effects of drugs has burgeoned. It's very important. When I analyzed the data in all those annuals, at least 2 of them, I found that 30%, that's the top line to the right, 30% of all the data in this field comes from anecdotes. And only 2.5% near the bottom comes from systematic reviews or meta-analyses. We need more of those, but we also need to interpret the anecdotes. So how do we do that? Well, there are 3 ways that I'm going to list. Between the eyes, designated medical events, and data mining. Here's the between the eyes. This comes from a famous American statistician called Joseph Berkson, who has his name attached to all kinds of things, but he invented the interocular traumatic impact test. If it's obvious, it hits you between the eyes. So Berkson's test provides a way of analyzing adverse drug reactions. And there are many between the eyes adverse drug reactions, things that are obvious as soon as you see them. They've got to be due to the drug. Here's an example. A guy puts a tablet of ecstasy on his gum, hoping to get a lift, and all he gets is a diamond-shaped ulcer on his gum with some inflammatory reaction around it. A good between the eyes, or actually in this case, between the teeth reaction, showing that this was the compound that did it. It may have been the ecstasy, it may have been the tablet itself, something, but that's what it was. Nothing else did this. So that's easy, but unfortunately there aren't many of those. We don't have many examples, so we need some other way of looking at this. Designated medical events, not a good term, but what it means is events that almost always are due to a drug. When you see any of these, you can bet your bottom dollar it's due to a drug. Probably, but not for sure. There are times when it's not. Now, when I show this picture to people, they say, ah, yes, thalidomide. But it isn't. This is an English artist called Aronson. That's her autobiography. And the sculpture is by a man called Mark Quinn. Shows her pregnant. A very daring sculpture. But it's been used as an icon for the disabled, for example, in the London Olympics, at the Paralympics. Aronson was born after thalidomide, and she has some genetic defect that mimics the thalidomide effect, but isn't due to thalidomide. So you can't always be sure. Most of the time when you see someone like this, yes, it's thalidomide, but sometimes it's not. You can't be absolutely sure. So it's not as good as between the eyes. But most adverse reactions aren't like that at all. You don't have that kind of evidence. You cannot generally tell the difference between the drug causing it and coincidence. So how do we tackle that problem? Well, there is a big centre in Sweden called the Uppsala Monitoring Centre, which takes in enormous numbers of case reports from all around the world. Individual stories that people send in to the UK authorities, to the American authorities, all over the world. They have more than 6 million case reports from many, many countries, and they analyze them using complicated statistics. But here's a story about a drug called topiramate used to treat epilepsy. When it was first introduced in 1994, there were no signals that it might cause glaucoma, but with time, as you can see, the graph drifts up, and suddenly you get a statistically significant difference showing that there is a signal here for glaucoma with this drug. It's not proof, but it's a strong signal, and it needs to be tested using a randomized controlled trial or an observational study. So there's 3 examples of how we use data. There's the definition of anecdote from the Oxford English Dictionary, the narrative of a detached incident or of a single event, told as being in itself interesting or striking. And I think that data should be defined as the plural of anecdote. Thank you.